Assalamu alaikum wa rahmatullahi wa barakatuh. In this video, I will explain to you the concept of network programming using TCP sockets under Java. In the next lecture, network programming using UDP sockets under Java will be explained in details. In the previous lecture, we have explained different topics related to sockets. Based on what you have learned previously, try to answer the following questions. What is a socket and how many bits it consists of? What are the sockets types? Can you compare between the sockets types? List and explain briefly some of the functional calls used in sockets programming. In the coming slides, we will introduce you to socket programming, init address class, which can be used for TCP or UDP sockets, but here we will explain the usage of init address class in TCP sockets. We will also give some examples for client-server programs that use TCP sockets, concurrent servers, their usage, and other information related to it will be explained as well. This diagram shows a client-server socket connection through the Extended Internet Service daemon. It is an open-source super server daemon, runs on many Unix-like systems, and manages Internet-based connectivity. STDN stands for Standard Input. It is a stream from which a program reads its input data. The program requests data transfers by the use of the read operation. Whereas stdout stands for Standard Output. It is a stream to which a program writes its output data. The program requests data transfer with the write operation. The server program is ready and listening through a socket uniquely identified by the combination of the IP address 192.168.100.1 and port number 3333. A client program can then connect its own socket to the server socket. After a successful connection using the three-way handshake, the client and the server can exchange bytes. Sockets are used to communicate between different processes, both locally and remotely. The TCP service provides a reliable byte stream transfer, which ensures the delivery of all the bytes sent from one node to another. In this figure, it shows that the server will be listening for a connection request from the client. The client who wants to transfer data from or to the server using a TCP socket must establish a connection first. This is done using the connect method. The three-way handshake is performed and a TCP connection is established between the client and the server. Now both the client and the server can read and write string of bytes to each other. Once the client has no more byte to send or to receive, the TCP connection will be closed. The socket is an interface between the application and the network. The figure highlights the main socket-related activity of the client and server that communicate over the TCP transport service. Next to the figure, you can see some of the functions used by the client to send a sentence and get the same sentence but in uppercase characters. Let us examine the code. The first code line is the creation of the client socket. This line creates the client sockets called client socket. The first parameter indicates that the underlying network is using IPv4 AF address family. The second parameter indicates that the socket is of type sock stream, which means it is a TCP socket. We are not specifying the port number of the client socket when we create it. We are instead letting the operating system do this for us. The second code line, client socket connect. Before the client can send data to the server or vice versa using a TCP socket, a TCP connection must first be established between the client and server. The client socket.connect initiate TCP connection between the client and the server. The parameter of the connect method is the address of the server side of the connection. After this line of code is executed, the three-way handshake is performed and a TCP connection is established between the client and the server. The third line of code will take input from the user. The string sentence continues to gather characters until the user ends the line by typing a carriage return, enter. The fourth line of code sends the string sentence through the client's socket and into the TCP connection. The client program simply drops the bytes and the string sentence into the TCP connection. The client then waits to receive bytes from the server. The fifth line of code is when the characters arrive from the server. They get placed into the string modified sentence. Characters continue to accumulate in the modified sentence until the line ends with a carriage return character. The sixth line of code will print the capitalized sentence at the client side, and the seventh line of code closes the client's sockets, which means closing the TCP connection between the client and the server. The java.net.inet address class is Java's high-level representation of an IP address, both IPv4 and IPv6. It is used by most of the other networking classes, including socket, server socket, datagram socket, datagram packet, and more. Generally, it includes both a host name and an IP address. inet address class has static factory methods that connects to a DNS server to resolve a host name. The most common is the inet address.getByName. For example, this is how you look up www.google.com. inet address equal to inet address.getByName www.google.com. Running the code will actually make a connection to the local DNS server to look up the name and the numeric address. If the DNS server cannot find the address, then this method throws an unknown host exception. We prefer to handle it with a catch clause. To display the result of getByName method, that is the IP address, you can simply use the method println. Here you can find a full Java code that uses the getByAddress method to retrieve an IP address of a specified host. The import statement can be used to import an entire package or sometimes import certain classes and interfaces inside the package. The import statement is written before the class definition. In this example, we are importing all java.net and java.utilities packages so we can use some of the classes in the code. The code line scanner input equal new scanner system in will wait for the user to input a value, that is the host name that he or she wants to resolve and get its IP address. If this code line is executed without an error address, you will get the IP address of the host name that you have typed earlier displayed on your screen. However, if the DNS server cannot find the address of the host name catch, the unknown host exception will work and the code line system out println could not find and the host name that you have mentioned will be displayed on the screen. After running the code, it will wait for the user to input the host name. The user typed the host name. In this example, it was www.google.com, and then the user hits enter. If the DNS query is successful, the user will get the IP address for that host name displayed on the screen. However, if the DNS query was not successful, then the unknown host catch will print the error message, could not find the host name. You can also retrieve the IP address of the machine that you are using by simply using the following Java code. Interpreting the code line init address equal init address dot get localhost will obtain the machine's IP address if there is any, and the code line system.out.println address will display the result on your screen. Otherwise, the catch unknown host exception will be executed and the code line system.out.println could not find the local IP address will be displayed as the error message on your screen. Running this Java code in my computer will print the local IP address of my machine. Try to run the same code on your machine and see what is the result that you will get. The figure shows a timeline of the typical scenario that takes place between a TCP client and server. First, the server is started, then sometimes later, a client is started that connects to the server. We assume that the client sends a request to the server processes the request, and the server sends a reply back to the client. This continues until the client closes its end of the connection, which sends an end-of-file notification to the server. The server then closes its end of the connection and either terminates or waits for a new client connection. This elementary TCP client-server socket makes the server capable of serving one client at a time. Later on, we will discuss other alternatives that allow multiple clients to be connected to the server at the same time. The Socket API, which is informally called Sockets, was originally created as part of the BSD Unix operating system. Versions of Sockets appear in more recent BSD systems, such as Linux and Mac OS. Microsoft adapted a version of Sockets known as Windows Sockets for their operating systems. The Socket API is a collection of socket calls that enable you to perform primary communication functions between applications programs. Examples of these primary functions are to set up and establish connections to other users on the network, to send and receive data to and from other users, and to close down connections. In later slides, we will explain the main methods used to perform some of these functions. Socket function creates socket on demand. It takes three integer arguments. The first one, protocol family, specifies the communications domain in which a socket is to be created, IPv4 or IPv6. The second argument is type, which specifies the socket type, which determines the semantic of communication over the socket. Stream, which provides sequenced, reliable, bidirectional connection mode byte streams and may provide a transmission mechanism for out-of-band data. And the second type is the SOC datagram, provides datagrams which are connectionless mode unreliable messages of fixed maximum length. The third argument, protocol, specifies a particular protocol to be used with socket, either TCP or UDP. Upon successful completion, the socket shall return a non-negative integer. Otherwise, a value of -1 shall be returned and error number set to indicate the error. Once the socket is created, the bind method of Java socket class binds the socket to a local address. If the specified address is null, then the system will automatically pick up a port number and a valid local address to bind with socket. The bind function takes the following arguments. Socket specifies the file descriptor of the socket to be bound. Address points to the socket address structure containing the address to be bound to the socket. The length and format of the address depend on the address family of the socket, whether it's IPv4 or IPv6. Address length specify the length of the socket address structure pointed by the address argument. Upon successful completion, bind shall return 0, otherwise -1 shall be returned, an error number set to indicate the error that happened. The listen function shall mark a connection with socket, specified by the socket argument as accepting connections, and the second argument, queue length, specifies the number of incoming connections that can be queued for acceptance. If more than the space specified in queue length, then the operating system will discard these new coming requests. The accept method of server socket class is used to accept the incoming request to the socket. The call to accept blocks until the connection request arrives. The accept method takes the following arguments. The first one, socket. Specify a socket that was created with socket, has been bound to an address with bind, and has issued a successful call to listen. The second argument is address, either a null pointer or a pointer to a socket address structure, where the address of the connecting socket shall be returned. The third argument, address length, points to socket length structure, which on input specifies the length of the supplied socket address structure, and an output specifies the length of the stored address. Initially, a socket is created in unconnected state, which means socket is not connected with any remote destination. The function connect tie a permanent destination to a socket, placing it in the connected state. An application program must call connect to establish connection before it can transfer data through a reliable stream socket. The function takes the following arguments. The first one, socket, specify the file descriptor associated with the socket. Address points to the socket address structure containing the peer address. The length and format of the address depends on the address family of the socket. And the third argument is the address length, specifies the length of the socket address structure pointed to by the address argument. Once the application program has established a socket, it can use a socket to transmit data. The write method only works with connected socket. A connection must be established first. The reason is that they do not allow the caller to specify address. This method accepts three parameters: socket, which contains integer socket descriptor; buffer, contains the address of data to be sent; length, specify the number of bytes to be sent. Usually write copies outgoing data into buffers into the OS kernel and allows the application to continue execution while it transmits the data across the network. If the system buffer becomes full, the call to write may block temporarily until TCP can send data across the network and make space in the buffer for new data. A process can use to receive data through a socket read function. The input operation read can only be used when the socket is connected. It has three parameters: descriptor, it gives the file descriptor from which to read data; buffer, specify the address in memory at which to store the data; length, specify the maximum number of bytes to read. Read extracts data bytes that have arrived at socket and copies them to the user buffer area. If no data has arrived, the call to read blocks until it does. If more data has arrived, then fits into buffer. The read method only extracts enough to fill the buffer. If less data has arrived than fits into the buffer, the read method extracts all the data and returns the number of bytes it found. When a process finishes using socket, it calls close function. It has one argument, and that argument specifies the descriptor of a socket to close. Now, test yourself and see if you can answer the following questions. Which method enables the server to wait for connection? How many arguments in the write method? Which method extracts data bytes that have arrived at socket and copies them to user buffer area? Concurrent connection-oriented server is the most general type of servers because it offers reliable transport as well as the ability to handle multiple requests at the same time. Connection-oriented servers implement concurrency among connections rather than individual requests. Connection between client and server handle more than a single request. The protocol allows a client to repeatedly send requests and receive responses without disconnecting the connection or creating a new one. To handle multiple simultaneous requests, most production servers are concurrent. A concurrent server can handle multiple requests at the same time. A concurrent server can handle a large set of clients at a given time, but the service each client receives might degrade proportional to the number of clients. To understand why concurrency is important, imagine what would happen with a sequential server if a client requests a video download over an extremely slow network. No other client request would be honored. With a concurrent design, however, a server will honor other requests while it continues to send packets over the slow connection. The purpose of fork function is to create a new process, which becomes the child process of that caller. The child process inherits many attributes from the parent process, but each child process will have a unique process ID. Typical uses of fork includes a process makes a copy of itself so that one copy handles one operation while the other copy does another task. Another usage is a process wants to execute another program. Since the only way to create a new process is by calling fork, the process first calls fork to make a copy of itself, and then one of the copy's child calls execute to replace itself with the new program. The fork join model is a way of setting up and executing parallel programs, such that execution branches off in parallel at designated points in the program to join, merge at a subsequent point and resume sequential execution. The fork join model can be considered a parallel design pattern. For each client, fork spans a child, and the child handles the new client. Then the child closes the listening socket and the parent closes the connected socket. There are two connected sockets, and each of the two connected sockets on the server host has its own socket receive buffer. The main difference is that there is a unique connection for each TCP client in a concurrent server compared to a non-concurrent server. The figure in this slide and the following slides will enable you to visualize the sockets and connection that occurs in a typical concurrent server program. First, figure 4.14 shows the status of the client and server while the server is blocked in the call to accept and the connection request arrives from the client. Immediately after accept returns, as shown in figure 4.15, the connection is accepted by the kernel and a new socket is created. This is a connected socket and data can now be read and written across the connection. The next step is the concurrent server is to call fork. Figure 4.16 shows the status after fork returns. Notice that both descriptors, listenFD and conFD, are shared, they are duplicated between the parent and the child. The next step is for the parent to close the connected socket and the child to close the listening socket. This is shown in figure 4.17. We come to the end of this lecture. If you have any question or inquiry, then please send an email to your lecturer.